Okay, hi AP kids. I am going to try to show you how you're going to do your parallel circuits lab completely online today. And I just want to show you some of the aspects of the Phet simulations that we're going to use. And I sent you the link, but look up top. We're going to be using the circuit construction kit, the DC virtual lab. And it's actually pretty cool. And it's probably easier to get better results using this simulation than our stuff in the lab. Hopefully, when we get back, we could do this in real life. But for now, I want you to check it out so we could get some lab time together. Over on the left side, you'll see all the components that we'll need in our lab. There's probably more. I didn't even check this out. But there's lots of things we could use over here. We essentially need a couple things: a battery. We need to start off with 3 resistors. Um, in part 2, you'll take out 1 resistor. In part 3 of the lab, you'll actually be using a light bulb. So we actually have those as well. Okay, so and you just set up your circuit. You're going to construct a parallel circuit. So these are the wires. And remember, the biggest feature of a parallel circuit is that they have to have branches or junction points for the current to flow. Okay, so I'm just going to connect wires to the ends of my resistors and to the battery, and you see how the connection points go from red to black when they're actually connected. You have to make sure that happens as well. There's lots of different ways you can construct a parallel circuit, but we're just going to make it look boxy because when you're just starting off, it's easier to make these boxy circuits so you could see how the branches connect and the actual junction points. Oh, we already have current flowing. So I'm actually, if I have something I don't want, I could actually highlight it and just delete it because I don't want anything to be flowing right now because I want to show you the rest of the circuit. Okay, a couple things. You're going to tap on each element and you're going to change the aspects of the element. So like in our lab, we don't want to use 9 volts. We're going to go down to 6 volts. And then, we're going to toggle this up or down for however many ohms we need. So I think we were using 22 in resistor number 1. If you can't get it exactly, then use the little arrow keys. And this is really cool. If you remember, we learned about the color codes. It changes the color codes when you get the right resistance. So I thought that was a fun little feature. And it's going too far. No, go back. So I think this one was 15. I don't know why that won't stop. I'm going to delete you because you're not behaving. Okay. So anyway, you tap the element, you change it to what you need. Okay. And then same thing down here. That's 10. That's perfect. Our battery is 6 volts. Okay. We're ready to go. A couple other things I want to show you. I'll actually connect the circuit so now we can see the charges flowing around. Check out the charges that are flowing. They have little negative signs because it's showing us electron flow, and it's going from the positive side of the battery out the negative side of the battery. But we learned in AP physics, nope, we don't follow reality, we follow conventional current. All right, so then these red arrows are going to represent conventional current. So I thought that was cool that you had the option for both. And you could kind of stretch this out and do whatever you need. Like it doesn't have to be small. If you're a perfectionist and you want to make it perfect with right angles and all that stuff, you could go, play all day with this. Other things I want to show you over here on the right side of the screen, wire resistivity. We're going to keep it tiny because we don't really want to account for wire resistivity because that will slow down our current too much. And then we're dealing with real life over here, but we want to use wires with negligible resistance. But I thought that was a fun feature. Same thing with battery resistance. We're going to pretend we have an ideal battery with no internal resistance because all devices, even batteries, have resistance within them. So we're just going to keep that at 0, but you can see if you toggle that up, it slows you down. So just make sure those two things are on 0. And notice this symbol over here. This isn't a battery that you drag on. This is, you get to change between like what the devices actually look like or close to what they look like in real life versus a schematic. And if I turn off the current flow for a second, that almost looks like the types of devices we draw in class, but do whatever one you like the best. Let's see, what else can we do? You could add the values of each device, which I think actually is helpful, so you keep track of which one's resistor 1, 2, and 3. And then we have our ammeters and our voltmeters. Okay, this is like a digital voltmeter we would use in class. And here we have our little ammeter. And here you're going to practice how to connect them and also getting readings. And a good thing about using the simulation is we could put, 4 ammeters in our circuit, and we don't have to keep disconnecting and reconnecting like we do in class because we have unlimited, equipment on this. So I'm just going to turn off the current for a second. I'm probably going to put it back on this. In order to get my ammeters in the right spot, I'm going to have to break the circuit and put them in series with whatever device. So if I put my ammeter here, I could connect this wire here. I'm going to need another wire here. I probably have to move stuff around, make sure I have everything connected. So that's showing my total current. I also want to measure the ammeter over here. So I'm going to measure each device, and see, I have to kind of move my resistors and my meters around to make sure my wires are all connected properly. Okay. I'm actually going to change the voltage on my battery so you don't get all the, oh, look what happened. I set my battery on fire. So that's really funny. But I'm going to change this so you guys can't get all the answers off of my page and you actually have to do the lab yourself. So just see, we're going to connect all our devices with wires. Okay. Put your ammeters in. Okay, so the way I have it now, I have my, I have all 3 ammeters hooked up to the 3 resistors. I actually have one for the total current. And then your voltmeter, you just put this around and just hold these 2 probes anywhere in the circuit, and you can measure the voltage over each device. Okay, so put it over the resistor, you get the voltage over that device. You put it over the battery, or really any 2 locations, and you get the voltage drop, the potential drop over those locations. Okay, so don't forget to screenshot your circuits. I would definitely have the values on so everything can be checked and we can see everything. And then for part 2 of this, you're going to remove resistor 3, do all of this again, all the readings again, and then part 3, you're going to replace all those resistors with light bulbs. Okay, and then when you're done, you could always set your circuit on fire because that's way too much voltage and the battery is actually burning. Okay. All right, so good luck. Let me know if you have any problems. I will be available by email, and I hope you have fun with this. Okay? Talk to you soon.